Hello ladies and gentlemen. What I'm going to show you how to do today is how to determine atomic number, protons, mass number, neutrons, and electrons from something called the isotope symbol. So I'm going to teach you how to interpret this symbol. It's predictable for every atom. So everything that you see here you should be able to apply to other atoms. So let's get started with first interpreting this symbol, and then I'll show you how to determine these numbers. So again, this is called an isotope symbol, and what it does is it tells us about an atom. So this is a symbol that tells us about what an atom it looks like on its interior. So this number right here, this 13, is called the mass number. Now that number is determined by doing the protons, and I'm going to abbreviate that P plus N. In other words, if I add up my protons and my neutrons, I get my mass number. Okay? And again, that's all the stuff that's inside the nucleus of the atom. Protons and neutrons are in the nucleus. They are the particles that have mass, or at least significant mass. Electrons have mass, but they're so tiny we pretty much ignore them. Okay, so this again is the mass number. Okay, then this is the symbol. Now, this symbol tells us the number of protons, or it tells us the atomic number. So I'm going to put under here atomic number. Now, the atomic number and the protons are the same thing. So if I said, hey, what's the atomic number of hydrogen? You'd say 1. Or if I said, hey, how many protons does hydrogen have? You'd say 1. They really are used interchangeably. They mean the same thing. Then the last thing that you'll have on this isotope symbol is this number right here. And this number represents the charge. Okay, so the charge. Sometimes you might see this just written as minus or as plus. When it's just minus, that means -1. So you might see it look something like that, but really that means -1. You could also see it as written just as plus. If it was just plus, that means it's a +1 charge. And how you determine the charge is the charge is dependent on the protons minus the electrons. Okay, so charge is equal to, so this number here is the charge, and it is equal to the protons minus electrons. Okay, so let's start using this to now interpret these numbers. You'll be given an isotope symbol at times, and I'll say, hey, tell me these numbers about it. So the first thing we're going to look at is the easy stuff. So first of all, the symbol is carbon. So I told you that that gives us our atomic number, and the atomic number is the same thing as the number of protons. So all I do is I look at my periodic table and I find carbon. Okay? If you look in carbon's box, you're going to see something that might look something like this. So you've got like your box for carbon. You're going to have C in the middle, and then you might have like a 6 either up at the top, or it might be over in the right-hand corner. It's going to be somewhere in there. And then you're also going to have something like 12.01. Okay? You're not going to use this 12.01, at least right now, but you will use this 6. This 6 is the atomic number. So again, how you determine the atomic number when given just this isotope symbol right here is you go to the periodic table, you find the whole number that is in the box with carbon. Again, sometimes it's up above it, sometimes it's to the right. That is your atomic number. Then we also talked about that atomic number is the same thing as protons. So that means my protons are also 6. Okay? Next thing that it's asking for is our mass number. Okay? Our mass number is, again, this number that's in the top left-hand corner of the symbol. So that means my mass number here is 13. Okay? So this is just information that's given to us really right off the bat. Okay, we could look at the symbol and determine this stuff. In order to determine neutrons and electrons, we have to use these equations that I just talked about. Okay, so I'm going to erase this real quick. And I'm going to show you how we find neutrons. So I told you that mass number is the same thing as protons plus neutrons. So I'm going to write a really simple equation, and that is mass number is equal to P plus N. What that means is if I to get my mass number, I'm going to take my protons and add my neutrons to them. Okay? Well, we know the mass number, right? We know it's 13, and we also know the protons. That's 6. So I can actually plug in my mass number and my protons here and then solve for n. So my mass number is 13. My protons is 6. And now I just have a really simple equation to solve. So I subtract 6 from both sides to try and get n by itself, and I'm going to get that 7 equals n. What that means is I have 7 neutrons. So I'm going to put that in right here. Then the last thing I need to determine is my electrons. So I'm going to erase this math right here and go to determine electrons. And I'm going to use this equation now. And that equation is charge equals P minus E. And P stands for protons, E stands for electrons. So I've got charge equals P minus E. Now, I'm going to use this right here in the top right-hand corner. So the charge on my carbon is a -1 charge. So what that means is I'm going to plug in -1 for charge. Then I've got my protons. Okay, my protons again are 6. So there's really, we can either manipulate this equation or we can think about it this way. 6 minus something gives me -1. So if you can already solve that, then great. If not, I'm going to show you how we solve it. So I need to get electrons, or E, by itself on one side. So I'm going to subtract 6 from both sides, and I get that -7 equals -E. Well, because I don't want to know what -E is, I want to know what E is, I'm going to divide both sides by -1. What that does is that flips my sign, and that gives me that 7 equals E. What that means is that's my number of electrons. So I now have 7 electrons. Okay? Now I want to give you a little bit of a graphical representation of what this atom looks like. Okay? Because I think it's really important that we know what that looks like. So basically, here's what I've got. Here's the nucleus of my atom. I have 6 protons, and those protons are positively charged. That's why I put that plus charge there. Then I have 7 neutrons. Okay? So notice if I add 6 and 7, this is my mass number. Okay? And my mass number, again, is protons plus neutrons. That's why my mass number is 13. Then, around the outside, I've got my electrons orbiting this atom, right? So the number of electrons that I have out there is 7. So I'm just going to write 7 E minus. So I wrote that minus there just to remind me the electrons are negative. And now, again, we think back and we go, okay, how did I get this -1 charge? Well, I have 7 electrons. In other words, 7 negative charges. But I only have 6 positive charges. So what that means is I have 1 more negative charge than I do positive charges, which is why the charge on this isotope or this particular ion would be a -1. Okay? So that's how you use the isotope symbol to find these protons, neutrons, electrons, mass number, all that stuff. Okay? I'm going to show you how to do it now the other way. What if I'm given this stuff and I need to write the symbol? Okay, I need to write the isotope symbol. So I'm going to show you that now. So now here's what I've got. I have 17 protons, 20 neutrons, and 18 electrons. And let's say that I asked you to write the isotope symbol. Okay? So here's what I need to do first. Okay? I'm going to look at my protons. Remember what I told you about protons is that protons identify the element. If I know the number of protons, then I know what element it is. Just like previously, I said, oh, it's carbon. So I look on the periodic table, I find carbon, I find the symbol C, and I go, oh, it's got 6 protons. You do the exact same thing now, knowing the protons. So here's what I do. I look at my periodic table. Again, you're going to have a box for each element. One of them is going to have a 17 above the symbol. Okay, it might be, again, on the right side or somewhere else in the box. So I've looked for that 17. And if I look at my periodic table and I look for that 17, you're going to find that that element is chlorine. So what that means is, that's my symbol, Cl. Okay, next thing I do is, again, I need to determine the mass number and I need to determine the charge. Okay, so, well, remember mass number is defined as protons plus neutrons. So it says I have 17 protons and 20 neutrons. Well, if I add those two together, 17 plus 20, that's 37. So that means I'm going to put 37 here. Then, again, up here in the top right-hand corner is where we put our charge. Now, this one has 17 protons and 18 electrons. So, again, the equation to find charge is charge equals protons minus electrons. Well, I've got 17 protons and 18 electrons, so 17 minus 18 is -1. So that means I'd have a -1 charge here. And that would be my isotope symbol. Okay? Now sometimes you also might see the atomic number written down here. So sometimes you might see it written something like this. Okay? But I also want to talk to you a little bit about what if it's neutral? In other words, we've talked about two atoms that have -1 charges. Let's say that just for fun, instead of having 18 electrons, let's say it had 16. How would that change my isotope symbol? Well, it doesn't change my protons, so I don't change my element. It's still chlorine. My protons and neutrons didn't change, so it's still mass number of 37. But now my charge changes, right? Because it's protons minus electrons, and my electrons just changed instead of 18 to 16. Well, that means now instead of having a -1, it'd be 17 minus 16, which is +1. So I would write a +1 charge. Now, again, what if there's no charge on this? How I would actually write it is like this. I would just have nothing there. But in order for that to happen, I would need to have the same number of electrons as I do protons. So this would need to be 17 electrons, and then we'd have 17 minus 17 gives me 0. Now, so I could like write a 0 here, but we don't do that in isotope symbols. If there's no charge, we just leave that 0 off, so it would look like that. Okay, so I hope you found this video helpful. Hopefully you can use that to determine your protons, neutrons, electrons. And then if you're given protons, neutrons, electrons, hopefully you can use that to determine your isotope symbol. So thanks for watching.